Good morning, everybody. Good morning. What's up, YouTube people? What's up to my Instagram peeps? It's a good day. Today is Thursday, and we are continuing the Khan Academy SAT problems. And today we're going to be looking at quadratic and exponential word problems. So this will be interesting. And we're all ready to go. So again, if you are checking this out on Instagram, you won't be able to see the whiteboard. You won't be able to actually see me attacking the problems. You'll just be able to hear me talking them through. So if you want to actually see the problems, jump onto my YouTube channel. Just go to YouTube, search for Scalar Learning, and you'll be able to see the live stream. You'll even be able to see the video after the fact, and you can watch me go through and solve these problems. All right, guys, in YouTube land, we're going to switch to the shared screen now. Let's go to shared, and let us begin. I think I've already got the problem on the clipboard. Again, I'm solving these problems for the first time. I have not seen them. It's part of the fun. Okay. Let's begin. A factory designed cylindrical cans 10 centimeters in height to hold exactly 500. Let me draw this out. I always like to draw this stuff out. So cans, so I'm going to make a little can here. Like this, a cylinder. And it is, 10 centimeters in height to hold exactly 500 centimeters of liquid. Which of the following best approximates the radius of this can? All right, we're talking about volume. It's saying that we want to hold 500 centimeters cubed. The formula for volume of a cylinder is actually area of the base. Okay, so area of that circle. So we'll say area of the base times height. And area, of course, is pi r squared times height, which is 10. So 10 pi r squared, and this whole thing equals 500. All right, so now we can actually go through and we can start to sort of refine this. Let's just we're solving for r. Now look, this is a calculator section problem, so we could use a calculator. Again, I don't have one. I usually don't use one unless I absolutely need it, so we're just not going to use it right now. I think I can handle this without it. So what we're going to do is we're going to divide both sides by 10. And then we're going to end, so this goes away. Of course, 500 divided by 10 is just 50 equals pi r squared. I'm also going to approximate a value for pi because, look, we're trying to solve for this value of radius. We're going to need that. So let's just pretend pi is about 3.1. Okay, so 50 divided by, let's see, 3.1. I think it's about 16. All right, makes that 48. 3.1 and then plus another 1.6. Yeah, I think 16 is about right. So we'll say this is really, let's write it up here. 3.1 r squared equals 50. Divide both sides by 3.1. Divide both sides by 3.1. Let's just say it's approximately 16 equals r squared. This means that then we have to take the square root of both sides to solve for radius. Square root of 16 is 4. So this is about what we should be getting for this radius over here. It should be about 4 according to this formula. They have an option for 4, so let's go ahead and check that. Make sure I did all my math correctly. Let's see, we got 4 centimeters right here. Okay, there we go. That works. Excellent. We are correct. And you can see here they solved it the exact same way. Let's go on to the next question, number 2. All right. Let me clear the board. By the way, the formula for radius, for area of a circle is on the SAT. So for example, if you flip to the front section, you don't have to have that memorized. You can actually look that up. And I believe they also have the formula for the volume of a cylinder as well. So that's not something you need to have memorized. I just happen to know it, but you don't need it. A minor league hockey team has been collecting ticket sales data over the past year. At a current price of $25 per ticket, an average of 4,000 seats are purchased. I'm just going to say $25. This is going to give me 4,000 tickets, $25 each. This is going to give me amount that's brought in. Just saying. They predict that for each increase in ticket price, 100 fewer tickets are sold. Okay. So as this goes up, right, we're losing 100. Which of the following functions best models the amount of money that the hockey team expects to collect from ticket sales? Y, all right, so Y is the total, based on X dollar increase in ticket price. This is very interesting. So what they've done is we're trying to figure out what's going on here as the ticket price goes up every time by $1. So on average, 4,000 seats are ticket. So we've got it basically that X, our X is, see, it's not only modeling the number, the price, it also this is an interesting problem because X models the number of the price increase as well as the number of tickets sold, which is really interesting because look how they've used it in this setup. Here, it's like it's affecting the price 25 plus X, right? Each $1 increase. And every time it goes up by $1, 100 fewer tickets are sold. So they've used the variable again over here to affect that 100. Now, I can tell you, just looking at this, I can tell you that I'm going to have to think about this for a second, but I believe A is got to be it because look, this is the only equation where we've got the modeling of ticket price going up. And then we've got here, the number of tickets being sold goes down by 100. Ticket price goes up by 1, this goes down by 100. Ticket price goes up by 2, this will go down by 200. So you can kind of see like this is the only one that makes sense. This is the reverse. This almost works, but we're subtracting $1 and the numbers are going up by 100. That may be true, but it didn't say that. It says for every $1 increase, we've got $100 fewer tickets to be sold. So this one is kind of interesting because, let me think about this for a second. This one almost might give you the same result if you FOIL it out, which they may not have even anticipated. I almost think it does. But anyways, we're going to go with A here. I think that's right. So let's go for it. And let's give it a shot. A. Now, I want to see what they say about B because B is, and A, of course, is correct. But the funny thing is, if you actually FOIL out B, I think it gives you the same. Because it's 2,500, 2,500. And then you do that one. That's negative. And that's, no, I'm sorry. The middle term is off. That's right, of course. So the middle term is different. Yeah, it's close, though. Okay. All right, let's go to the next one here. We're going to delete this. All right. So here we go. Question 3 of 5. Rajiv has $175 that he earned from his summer job. He puts the money in an account that yields 4%. Okay, so we got 175. We're getting 4% interest compounded annually. Assume that Rajiv does not make any other deposits or withdrawals from his account. After how many years from the time he deposited the money will he have at least 200 in his account? Okay, we're talking about compounded interest. Man, I guess they want you to have this formula memorized. I think I remember it. So it's 170. It's the initial. This would be a good one for the calculator. I'll try my best to do it without, but it's 175, which is the principal. Here, let's look at like, I think we'll just say X. It's like final, but it's 175 times 1 plus R over 100 to the n year. Okay, so what is this? What is our rate? Rate is 4. So it's 175 times 1 plus 4 over 100 to the, and what we're solving for is actually n. And actually our X, our final value is 200. We don't need an X here because that's what we're looking at. Okay, now that we know this, we can go ahead and solve this. And this right here, by the way, this is 1.04. So we take 200 equals 175 times 1.04 to the nth power. Okay, so you know what? This one is, I'm really going to use a calculator because this is a little crazy. So first thing we're going to do is we're going to divide by 175. 175, right? All right, let's get rid of that. So let's go over here and let's jump on the calculator. I just use the Google calculator. So we're going to do 200 divided by 175. I guess this was round to 1.14. We got 1.14 equals 1.04 to the n power. Now, when we have something like this, we're trying to solve for the number of years, we're actually going to have to take the log, this is kind of a complicated problem. I'm trying to think if there's an easier way to do this, but I don't think so. So we basically are going to take the log of both sides. Let's say that's usually how you kind of work with something like this. So we take, let's say, log of this, and then it'd be n times log of that. So it would end up being, the way that log works is you take the log of this of 1.04 and you can bring the exponent down, equals log of 1.14. Okay, and then we just divide both sides by log of 1.04, including this side. I'm running out of room here. Let's put it up here. So it's ended up being log of 1.14 over log of 1.04 equals n. So let's go ahead and do that here. Okay, so we'll say log of 1.14 divided by log of 1.04 equals, whoops, this fell here, equals, I think it was 3.34. So it's approximately 3 years. Now, this is interesting because after how many years? No, actually we want at least $200. So it has to be D. Excuse me, because it's 3.34. So 3 years he won't have the $200. So D is going to be our answer. Now this is I'm trying to think. It's like usually when you solve a logarithmic problem, an exponential problem where you're solving for the exponent, you got to use log. It's the only way to bring the exponent down and solve for it. That's a pretty high level problem. So let's just make sure they solved it via log as well. 200, 1.14, and you know what? So look, I'm looking at the answer. They didn't use logs to solve this. What they did was they did a little plug and chug. I'm usually not a great fan of plugging and chugging, but you could, in this case, I would say that's all right. If you don't remember how to use logarithms, you should know how to use them for the SAT. But if you're drawing a blank, that is an acceptable way to do it. All right, interesting. That was a pretty tough one. Okay, let's go to number 4 here. And this one looks pretty long. All righty. So that was interesting. Compounded interest, where you actually have to memorize the formula. Because I've seen compounded interest, but a lot of times they'll give you that formula. All right, here we go. Question number 4. Ramen is a Chinese noodle made by repeatedly folding and stretching dough to make noodles of varying thickness. A ball of dough is rolled into a long rope 2 centimeters in diameter. So a ball of dough, let's say a ball of dough is rolled into a long rope. So rope 2 centimeters, what does that mean? A cylinder, I suppose, like this. Let's assume it's something like this, kind of drawing it out here, right? And we'll say this is 2 centimeters. Okay. One end of the dough is held in each hand, and the dough is stretched and folded, making 2 separate strands. So it's holding each one, and the dough is stretched and folded, making 2 separate strands. The process is repeated until the strands are the desired thickness. Assume that each time the dough is stretched, the thickness of each noodle is so assume that each time the dough is stretched, the thickness decreases. Let's put a variable t is decreased by 30%. Decreased by 30% also means, I'm just going to jump to this and say it's 70% of what it was. So whatever the thickness is, each time it's going to 0.7 of that. How many folds will be needed to produce noodles whose thickness is at most 0.5 centimeters? So this is another exponential equation where we're like t times thickness times 0.7 to, some exponent. That would be how many times. Thickness was 0.5 at most. So it's actually got, what that means, let's set it up right. This is actually an inequality. So where it's less than or equal to 0.5. So what we got to do now, and what's our initial thickness, is 2. So it's 2 times 0.7 to the x. So less than or equal to 0.5. So again, this is where our exponent makes sense, because every time, when they say every time it decreases by 0.7, that's where we're going to use this, the amount of change to a variable. So it's like, if they do it one time, it'll just be 0.7 times this. 2 times, think about it. 0.7 to the second power is really 0.7. And then we're reducing it again by 0.7. You see how that works? It's 0.7 to the second power. Then it would be 0.7 to the third power, so on and so forth. So this is kind of how we'd set it up. And we can solve this once again using logarithms. So we're going to divide both sides by 2, and 0.5 over 2 is just 0.25. Right? So 0.25 equals 0.7 to the x, or sorry, less than or equal to 0.7 to the x. Now I'm going to take the log of 0.25 is greater than or equal to log of 0.7, and then we can bring the x down. That's just a logarithmic rule. If you don't remember, that's why we can use logs like this. It allows us to bring that exponent down. And then we divide both sides by log of 0.7, log of 0.7, and that'll give us our answer. So let's go ahead and do this on the calculator. So we've got log of 0.25. Whoops, what's all this craziness? Log of 0.25 divided by log of 0.7. 3.88. So let's just say 3.89. So we'll say x is less than or equal to 3.89. So, and let's make sure I have that right? Has to be less than or equal to 0.25, right? Did I set this up right? So that means log is less than 3.89. Yeah, but it should be who's at most. So it should be the other way around, right? Because it's got to be greater than 3. So anyways, let's just make sure I did this right. So 0.7 to the x has to be 0.25. So 3. So the point is, it's in between 3 and 4, right? I'm trying to figure out if it's either 3 or 4. Like, my gut is telling me it's 4. So let's check this out. 4 folds. I'm gonna take my first equation here and just check it out. We're saying at this point, we're starting with 2 inches. So 0.7, it'd really be like this. It's 2 times 0.7 times 0.7, okay, times 0.7 equals, that's 3 times, and then times 0.7 again. So it's 4 times. It has to be 4 times. That's going to take us to below 0.5. Something got a little confusing to me, because this is saying, hey, x is less than or equal to 3.89. It's got to be 4. All right, so we're going to go back here, and then we'll take 4 folds before it's less than 0.5. Okay. I'm just going to look at their equation here. And yeah, so you see how they have it set up? They had 1 minus 0.3, but then right here, they have the same equation. And that's it. And then they did a little plug and chug. They're not doing the logarithms, so we can even do that next time if you're not comfortable with the logs. Let's go to this guy. Final question of the morning. These are hard problems. These are tough problems. So something to practice, to work with, especially with the setup. I mean, I'm looking at them and I can tell, I'm sure they must be a little bit confusing. So definitely practice with these guys. Again, we're in the quadratic and exponential word problems. So check that section out to get some more practice. All right, this one they give us a formula, which is always nice. The seat on a tractor is mounted on springs in order to absorb impact. The driver sits on the seat, and the springs compress a distance of x meters. X meters m. What is that? Oh yeah, okay. As the springs compress, potential energy P, so this is potential energy right here, in joules is stored in them according to the equation above. Okay, cool. The spring constant K describes the strength of the springs in newtons per meter. If the springs have a spring constant of 25,600, this is, and it really annoys me when they do this. They're literally, in my opinion, my humble opinion, they're throwing out a whole lot of units, and I feel like it's done to be confusing. Again, if you're tuning in right now on Instagram, I'm solving SAT problems live. If you want to check these SAT problems, actually see the whiteboard, go to my YouTube channel. Just go to YouTube and search for Scalar Learning, and you will be able to see this live, actually watch the problems being solved. So now, anyways, I believe they're throwing all this stuff out to be confusing. Let's peel away all the units. We're just plugging in 25,600. That's our K value. So we got P equals 1/2, and K is 25,600. Now look how much nicer this was going to start to look, times x squared. And now we've got a nice equation. It says, how much must the spring stretch? Again, what does it stretch? Where's the stretch or compress or whatever? We're talking about the x value. How much does this thing have to stretch in order to store 8 joules? And remember, the amount of energy is just our P value. Look, once we can plug in the values, this isn't that bad. Now we have 1/2 of 25. And all we got to do, solve for x. Simple. Right? It's simple once you can actually put the pieces in place. Very hard until you can do that. I'll try and go as long as I can without a calculator here. To get rid of that 1/2, I'm going to multiply both sides by 2. Okay. And we get 16. This knocks this away. 16 equals 25,600. X squared. We're going to have to use a calculator now. So we're going to divide both sides by 25,600 to isolate x squared, right? 25,600. We're going to get some crazy decimal. X squared equals, could keep it a fraction, but this will be easier. So 16 divided by 25,600. So we got 16 divided by 25,600. And we get 30625. So 0.0000625. And I bet you they have that as an answer, and they do. All right, but don't jump to this answer because we're not done. So this just is this equals x squared. We got to find x. So now we got to take the square root of both sides. Do I have an idea what that is? 5 cubed, 125. I think this is 25. I think or it should be like 0.025 or something. Yeah, I think it's going to be B, but let's actually take the square root. I think the reason why I know that is because if I remember correctly, 25 squared is 625. So we're going to now take the square root of that answer, right? Square root of 0.000625, and it is indeed 0.025. Boom. Now we have our answer. You see how tricky they get. They can people, I bet you can do all this setup right beautifully, and they choose the wrong answer. Now let's make sure we're right. We always have to double check. Enter 0.025, and it is indeed correct. So that's pretty awesome. That was a hard section. Let me go back. I'm going to turn the shared screen off here. So look, these problems today that we went over were pretty tough. Strangely, that last one I think was easier than the rest. But you know what made it difficult? What made that last one difficult is the fact that we have all these units running around. It's a lot of confusing verbiage, and I think that's really what the SAT in part, that's what it's become about in a lot of ways, is how can you break down the words? How can you decipher what's going on? Create a formula that's correct and then solve for it. But solving the formula, is always less difficult, once you have the variable isolation principles down. But so it is what it is. If you did find this tricky, you can always message me at huzefa@scalarlearning.com. I'll do my best to answer your questions. And again, check out my YouTube channel for more videos on solving Khan Academy practice problems. You can also check out my video course on the SAT called Power 800 SAT Math. That's on Udemy. You can check links below for a discount code, coupon code, so you can get a nice discount. That is my thank you for being a loyal YouTube follower, Instagram follower as well. And that's it. I'm excited for the day. Got to get ready, got to get to school. So you guys have a great day. Thanks so much for joining. Peace.